Hi, today's presentation will be on assassin snails, a relatively understudied species and one of few predatory carnivorous freshwater snails. The scientific name for these snails is Anentom helena, but they are also known as bumblebee snails because of their typical black and white striped patterns. Due to genetic variations, their shells may also come in slightly different colors. The yellow and black stripes sometimes mix to create a solid black or blonde shell pigments. Assassin snails also have a proboscis, as seen in the top right image, that is abnormally long for a snail of that size and is used to detect their prey. Assassin snails can spend days buried under the sand with only their proboscis poking above the sand. Once prey is detected close to its proboscis, it will come out of the sand, impale the other snail with it, and consume the prey snail without venom, just latching on and eating it alive. This is where the name assassin snail comes from. Assassin snails also have an operculum, also known as a trapdoor, that allows them to close off their shell, acting as a barrier to pathogens. Unlike some other snail species, this will enable them to contract fully into their shells. Here's a picture of an assassin snail with its shell removed. The operculum is visible beneath the snail's foot. We can also see the proboscis. Notice how the snail's eye is quite far back into the shell and is not in a great spot to be used. These snails do not rely on vision as their primary sense, as we do. They use other senses, like smell, to guide them to their prey. Assassin snails are sexually monomorphic, meaning their genders cannot be distinguished without examining their reproductive organs more closely. They have a generally low fertility rate, only producing 1 to 4 eggs per clutch. They are gonochoristic and fertilize internally, meaning that both male and female snails must be present to produce valid eggs. Depending on water parameters, the eggs are less than a millimeter in diameter and hatch within 1 to 2 months. This means that during this time period, the eggs are susceptible to being eaten and destroyed. Assassin snails were officially discovered in 1847 by German malacologist and translator Gerhard von dem Busch in the Philippines. Their only human use is the pet trade, giving them a relatively low economic value. Because of this, they are vastly understudied. They are harvested wild in their natural habitat and bred in captivity globally. The appeal of the assassin snail to an aquarist is that these snails will hunt and eat species of pest snails that would otherwise overcrowd your tank, regulating populations. In this image, you can see aquarists breeding these sought-after snails. My research question asks what the role of assassin snails is in their native habitats, and how they can benefit non-native habitats. In the bottom image, you can see an assassin snail eating a Malaysian trumpet snail, a common snack for them. Assassin snails are native to Southeast Asia, but their range has been reported to expand gradually, both naturally and through the pet trade. Their niche includes prey snails and carrion, and tropical freshwater environments. They likely evolved gradually due to a general trend in the shortage of plant matter due to an overpopulation of snails, which caused them to gradually move up a trophic level. In their natural habitat, they help regulate populations of other snails, keeping a natural balance of species. Additionally, they help clean up carrion. They provide a small economic benefit to the local people of Southeast Asia, who harvest them to be sold into the pet trade. There is only one reported and studied case of assassin snails surviving in a non-native habitat. This is in a Singapore river, as shown by the arrow in this picture. As climate change changes lakes, assassin snails can inhabit more places in the tropics. The potential risk of assassin snails as an invasive species is generally low because of their low fertility rates. Still, it depends on factors like the location, other predators, and the population of prey snails. The pet trade and people dumping aquariums into the wild poses the most significant invasive risk. Indian scientists are worried about this, since many of their lakes could suffer because of an addition of assassin snails. Since there's only been one case of assassin snails introduced successfully into a new habitat, it's an unprecedented subject, and we can never know for sure what the outcome will be. Bithynia siamensis, a common assassin snail meal, is an intermediate host of a species of trematodes susceptible to humans, and can make people very sick with this parasite. When assassin snails eat Bithynia siamensis, the trematodes living and breeding inside them die. In this way, assassin snails are indirectly helping humans. This could potentially be used in the non-native introduction of the species. In conclusion, assassin snails generally have a positive effect on their ecosystem, balancing the populations of other snails, and while they are a potential threat as an invasive species, it's unlikely that they would harm an ecosystem, although it is hard to say. Assassin snails are also an effective biological control of trematodes, indirectly preventing human illness. So if you ever find yourself buying livestock for a new fish tank, consider this little stripy fellow.